Welcome to a tutorial about bar modeling with Mr. Dudrick. The purpose of bar modeling is to move from the concrete to the pictorial, then from the pictorial to the abstract. Concretely, we can see that there are 1, 2, 3, and 4 green snap cubes. We can also physically see and count and touch the fact that there are 5 red snap cubes. We can physically put them together to show a sum made up of the 5 red parts and 4 green parts. We can then physically count 1, 2, 3, 4, 5, 6, 7, 8, 9. Once students have had enough time to investigate with the concrete manipulatives, they're able to draw a picture of what's in front of them. We can see that there are 4 green cubes drawn and 5 red cubes drawn. We are now looking for what this total would be. We can label 4 and 5 on either side. With the sum, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can label the sum to be 9. Another picture we can draw is the number bond, showing that 9 is the total made up of the 2 parts, 4 and 5. By first investigating concretely with snap cubes or other types of manipulatives, we can then progress to creating a drawing represented by the concrete use of those manipulatives. When we operate on the abstract level, we can show the algorithm 4 plus 5 to be 9, because in our mind's eye, we can picture 4 in one section, 5 in another, and when added as one long bar, we have the total to be 9. This is how we can encourage the children to operate from concrete to several pictorial methods, getting us to the ultimate goal of fact fluency abstractly. Calvin cycles 3 kilometers, 287 meters from town A to town B. He then cycles 5 kilometers, 905 meters from town B to town C. Let's draw a bar that represents each of those values. The first would be 3 kilometers, 287 meters. The second bar would represent from town B to town C, a distance of 5 kilometers, 905 meters. Let's label each bar. First we have from town A to town B, then from B to C. What we want to know is the distance traveled in all. The visual we create shows the total distance would be the sum of 3 kilometers, 287 meters, plus 5 kilometers, 905 meters. When we add those values, we know that 1,100 meters, we can exchange 1,000 meters as 1 more kilometer. So we get a sum of 9 kilometers, 192 meters. If Mrs. Lim buys 135 kilograms of beans and divides them into 9 bags equally, the bar we would create would represent 135 kilograms. What we're going to do is divide it equally into 9 parts, and we want to know what would the mass of one of those bags of beans be. So we're going to divide 135 kilograms by 9 bags. In our next slide, we'll show the division algorithm specifically. We have 135 kilograms divided by 9 bags. To show the weight of how many kilograms would be in each bag. So performing the division, can we put 10 kilograms in each of the 9 bags? We can, which tells us we've distributed 90 kilograms. From the 135, we have 45 kilograms still to be divided equally. And we know that if we were to put 5 kilograms in each of those bags, we would use all of those kilograms. So, if we put 10 in the first time and 5 kilos in the next time, we have 15 kilograms per bag. If each of the bags of rice has a mass of 9 kilograms, and there are 7 bags, then the bar model we would set up would show those 7 bags each having a 9 kilogram mass. What we want to know is the total in those 9 bags. So we have a multiplication problem to solve. We know that 9 kilograms times 7 bags would give us 63 kilograms in all. If Boris loads 45 kilograms of meat in the van the first hour, then he loads some more meat in the second hour. We don't know that value. However, we do know the total amount that was put in the van in both hours to be 98 kilograms. So if we take the total and subtract from it one of its parts, we'll find the second part. We can also represent this with a number bond. We have 98 being 45 plus what value? To find that, we're going to perform the subtraction problem, 98 minus 45. We find the difference to be 53 kilograms that were packed in the van during the second hour. Next, they ask us how much more meat was loaded in the second hour than the first. So, we'll subtract the first from the second hour. We need to trade one of these tens, leaving us 4, for 10 tens. If there were 3 tens and we add 10 tens, we now have 13 tens. From that, we take 5 and are left with 8. So there are 8 more kilograms loaded in the second hour than the first. Jackie sells 26 liters of gas in the first hour. He then sells 9 liters less in the second hour. So we don't know this value. We do know it happens in the second hour, and it's less. It's also less by 9 liters. Our task has two parts. We need to find the total amount of gas sold. But before we can do that, we must find the amount of gas sold in the second hour. To find the value of the gas sold in the second hour, we'll take the 26 liters sold in the first hour, and 9 less than that would be the value sold in the second hour. So we need to trade to find that 17 liters were sold in the second hour. So altogether, 26 in the first hour plus 17 in the second hour give us a total of 43 liters of gas sold in all. We can show the number bond of 26 minus the 9 gives us that value of 17. We can also show that 43 total liters is a result of 26 in the first hour, 17 in the second hour.